we've talked about what the future value is. So now let's figure out how to calculate it. First, there's this concept called compounding. And so compounding means that we're actually computing a future value. So we're computing that future value of some amount that we want to figure out what it will be worth at some point in the future based on a certain interest rate. So in this example, we have a present value of $700 that we're going to invest for 3 years at 10%, and therefore it gives us a future value of $931.70. So here's our formula. The future value is equal to the present value times 1 plus the interest rate raised to the number of periods. So there's 4 ways to solve time value of money problems. The cash flow timeline that we just saw, which I don't know that I would call it a way to solve time value problems, but it is a way to lay it out. You're still going to have to solve it using the equations, which is the second way. Third way is using a financial calculator, which is what I recommend because it's handy and it's fast. And the last way is an electronic spreadsheet. Now, I'm not saying that that's not a good way to do these, but if you're in a face-to-face class and you have an in-class exam, you're not going to be able to use Excel. So you're going to need to know how to use that calculator. So let's look at that problem again. The future value of $700 invested at 10% per year for 3 years. So what they're doing here is they're figuring out the future value at each period. So this is the future value after 1 year, 2 years, and 3 years. And so using the equation, we'd plug in $700 for the future value. The N is 3 because it's a 3-year investment. And so we multiply that present value of $700 times 1.1 because we have a 10% interest rate raised to the 3rd power. In the financial calculator, we're going to put in N as the number of periods, so that's 3. The interest rate is 10. We're going to put in a whole number in the financial calculator. The present value is actually negative 700 because if I'm going to invest this, I'm going to take money out of my pocket and give it to my banker, so that's a cash outflow to me. So cash outflows are negative, inflows are positive. There are no payments over the course of that 3 years, so that would give me, if I hit compute future value, a future value of $931.70. Now, in a spreadsheet like Excel, you see in column A, we've got all of the labels for N and the interest rate, just like you would have on the calculator. And then we plug those all in, so N is still 3, but now in Excel we have to put the interest rate in as a decimal. Present value is still negative 700, no payments, and this is an ordinary annuity. We'll talk about what that means in just a bit. And we're solving for the future value. So the equation that we're going to put in is future value is equal to the rate, which is B2, comma, number of periods, which was in B1, comma, the present value, which was in B3. They have it reversed. Excel will walk you through it and tell you what comes in what order. And then, I see, there was no payment, so we can skip over B4. And then the type, B5, which we didn't have to use either because the default is the ordinary annuity. So speaking of an annuity, remember we talked about the annuity is a series of equal payments that come at regular intervals. Well, there are actually 2 types of annuities. An ordinary annuity is the most common. The calculator in Excel will default to this, but this just means that the payments or the cash flows occur at the end of each period. An annuity due means the opposite. The cash flows occur at the beginning of each period. So here's an example of a 3-year ordinary annuity of $400 at 5%. So that means we have regular payments of $400 and an interest rate of 5%. So the future value of that annuity is $1,261. So the equation is a little ugly. The final equation is the payment times this fraction, 1 plus r to the n minus 1 divided by r. But most of the time you're going to use your financial calculator. So in your financial calculator you'll put 3n, 5 for the interest rate, 0 present value, because you're not starting off with anything, you're going to make payments. So payments -400, or in the calculator you'll put the number first. So -400 payment, and then you hit compute future value. Now, of course, as I've mentioned before, I explained the calculator solution based on the TI BA2 Plus. If you're using one of the HP calculators, it's going to be basically backwards for the keystrokes. So our solution for this is still 1261. Now, what if it's an annuity due? Remember, if it's annuity due and annuity due, the difference is that the payments are at the beginning of the period. So we're basically just backing up one period if you look at this on the timeline. So because we're backing up one period, we're going to earn interest longer, so the future value will be higher, $1,324.05. Using the equation you see in the red, there's an extra little part that you have to add to this. In the calculator, what we have to do is change our payments to the beginning of the period. And so to do that in the TI, you're going to hit the number 2, and then you're going to hit payment, because right above that you'll see where it says begin, and then it'll show you in the window that the payments are set to the end of the period. So you'll hit second enter, and that will change it to begin. And so for as long as you have the payment set to the beginning of the period, you'll see the little BGN in the window. So if you don't see BGN in your calculator window right now, you haven't done something quite right. So now if we do that and put in the same information, we'll get that 1324.05. Now remember, our third cash flow pattern was an uneven cash flow stream. So for an uneven cash flow stream, the cash flows are different even though we have more than one cash flow. And so here with the timeline, we're calculating the future value of each one of those individual cash flows. So in the equation, all we're doing is just calculating those future values and summing them up.